Okay, so now we're on to problem 6 in our classical mechanics book. And the problem says, by evaluating the dot product, find the values of the scalar s for the two vectors. And we're given vector b, which is x hat plus our scalar s y hat, and c which is equal to x hat minus our scalar s y hat. They're also orthogonal, which is important. And then it wants us to explain it with a sketch. I wasn't able to crop out the 1.7, so just ignore it. Well, let's look at our dot product. That's vector b dotted with c is the magnitude of b times the magnitude of c times cosine the angle between them. Well, it mentions they're orthogonal, and if you don't know what orthogonal means, right here, you can think of that as just being perpendicular. Well, vectors that are perpendicular, the angle between them is 90 degrees. And what's cosine of 90 degrees? 0. So that tells us that our dot product is equal to 0. And this is a fun little thing, fun and useful thing to remember, is if your dot product is equal to 0, that means that your two vectors are orthogonal or perpendicular. Well, what exactly is our dot product here? Well, we can think of it as what? We have 1 minus 1, right? 1 times 1. And then plus, what are we left with? I'm sorry, those are positives, not negatives. 1 times 1, I put a negative there, I was looking ahead. And then times what? S times negative s. And that should be equal to 0. So all we did was we multiplied our two components. The x hat, that just has a coefficient of 1. And then our y hats just have the coefficient of s hat. So finally, we're left with 1 minus s squared is equal to 0, or s squared is equal to 1, or s equals plus minus 1. So the value for a scalar is s is plus or minus 1. Let's think about that a little bit. What if s equals 1? Well, if s equals 1, then vector b is just x hat plus y hat. And vector c is what? Vector c is just x hat minus y hat. That's the result if s equals 1. But there's the other case of s equals negative 1. And if s equals negative 1, we'll get the exact same thing, only our flipped signs. So those are the two possibilities. Now, what does this mean graphically? Well, it's a two-dimensional. We're dealing with x and y's. So it's two-dimensional. We have our origin here at the center. And then, so for the first one, we have the point 1, 1. And then for the other one, this is when s is equal to 1, by the way. So this is vector b. And then for c, it's the same thing, only it's going to be down. That should be perpendicular. So this is the point 1, 1, and this is 1, negative 1. Okay? Hopefully that part makes sense. But we also have to think about if s equals negative 1. Well, if s equals negative 1, the only thing that's going to be different is now this is vector c. This was vector c before. And now this is vector b. because, like we said before, the only thing that happens is basically your equation switch. That is my cat being very loud. So yeah, that's all there is to it.